2 weeks before a significant pattern shift? Really? I am Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast. It's the week starting Sunday, March 9th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
If you haven't subscribed, please subscribe. Click the Stormsurf icon down in the lower right-hand corner of the screen. If you enjoy the video, be sure and give us a thumbs up. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may hit the super thanks button down below, the heart with the $sign in it. With that, I'd like to thank the folks that donated last week. Evolution Moto, Clay Goose, Tim Caston, Our Predicament, Peter Carpenter, Pierre Morton, Elliot Harris, Monta Drifter, B. Nadine. Quite a list, and all these are repeat donators. Very much appreciated. Thank you so much. With that, let's get to work. We'll start by looking at significant wave heights for the entire planet. Starting in the North Pacific, we have a gale with 28-foot seas right over the North Dateline region here. That line, there's the Dateline, and these are the Aleutian Islands. Otherwise, pretty quiet pattern. North Pacific, South Pacific, things quiet, not surprising given the time of year. North Atlantic, little bit pieces of gale, 20-foot energy or 20-foot seas pushing towards Morocco and some other bits of things trying to get organized, but nothing particularly notable at the moment. Down in the South Atlantic, a gale with 20-foot seas targeting South Africa. Again, not particularly interesting. And a gale, we'll call it southwest of Australia with 32-foot seas. Here, the highest seas right there over this entire domain. Aimed somewhat at Australia, and a more robust pattern is forecast over the coming week for the Indian Ocean. So there is hope down south, finally, but that is not the pattern shift I was talking about in the title. But let's start by looking at current conditions. We're going to look at the buoys up off the Pacific Northwest, starting at Grays Harbor, Washington, buoy 036, right there off the Columbia River. We're looking at all the energy that's hitting this buoy, all the way up from 33.3 second period. That'd be very long period, energetic swell energy, 1/10 of a foot. Not much energy when it's all said and done. But you see and the chart goes the whole way down to 5 second period, just pure wind chop. You see a nice little bump here in the 15, 16 second period range, and another bit of some wind swell in the 9 to 10 second period range. Let's see how well the algorithm does at teasing this all out. Not bad. Primary swell. 3.9 feet at 15.8 seconds from 277 degrees. That theoretically would make surf about 6.2 feet. That does not account for any swell-enhancing bathymetry. It just assumes a generic beach break sort of thing. So if you're surfing some great reef break, you can up to double the theoretical wave face height size. Secondary swell, 5.7 feet at 10.1 seconds from 257 degrees, also making surf in about the 5.7 foot range. And then the chop height, 2.3 feet. Anything more than about 2 feet, it's pretty ugly. Up to 3 feet, you wouldn't even want to surf it. The prime, you really want, 1.5 foot, something like that. Then we go down to Point Reyes, California, 029. That Point Reyes off of just north of San Francisco there. Same sort of profile, a little bit of energy at 18 seconds, but most in the 13 to 14 second period range, and not as pronounced a wind swell bump as further up north. Primary swell, 4.2 feet at 14.4 seconds from 300 degrees, again making surf about 6 feet. And the secondary swell, 4.1 feet at 10.6 seconds from 283 degrees, with the wind swell, we'll say 4.4 feet, and again kind of a choppy, ugly mess. Down to Southern California, the Point Loma South buoy there off of San Diego, buoy number 191. Same sort of profile, just attenuated a little bit by the Channel Islands, but some energy there in the 14, 15 second period range and lesser period wind swell. Primary swell, 2.7 feet at 14.6 seconds from 279 degrees. theoretically making surf at 3.9 feet. Yeah, there were waves chest high, maybe even higher at select breaks in Southern California this morning. And secondary swell, 2.6 feet at 10.4 seconds from 273 degrees, with a estimated surf height at about 2.7 feet. And of course, chop height, pretty much non-existent. And then finally over to the Hawaiian Islands, Waimea Bay buoy number 106. We see a bit of energy in the 12 to 13 second period range and a bit of wind swell in the 7-second period range here on the chart. Let's tease it out. Primary swell 4.6 feet at 13.1 seconds from 320 degrees, theoretically making surf 6.1 feet. And then that secondary swell, the wind swell, 6.1 feet at 8.1 seconds. It says 110 degrees. I don't know. It's probably wraparound energy of some kind because there's pretty strong trades over the islands, theoretically making surf 5 feet at somewhere. So let's do a quick review around the planet. We're going to do what's happened in the past week over all the planet's oceans, starting in the North Pacific. We're on Sunday, March 2nd, 18Z, so about 10 o'clock California time. We see a little gale developed here west of the North Dateline region with 28-foot seas on Tuesday. That pushed east, kind of lingered into Friday and even Saturday. Leading edge of that swell pushing into California. I think it started on Saturday afternoon, is hitting as of Sunday. Another gale developed right behind that. A little bit stronger one on the North Dateline region. And let's see, there we are at current time, 28-foot seas over the North Dateline region. Not aimed so well at Hawaii, more off to the east at the U.S. West Coast. And then to the South Pacific. Now, you notice just about 6 hours ago that in reviewing the Hindcast, I forgot to point it out, but there was this ice anomaly or strange thing that we've been dealing with. It was gone last week. It reappeared this past, a couple of days ago. But now with like the latest run of the model, it's gone. And this is accurate. I actually went and looked at satellite data and satellite imagery of icebergs and all that stuff floating around. And NOAA has an actual site that tracks all that stuff, believe it or not. And for the most part, waters are ice-free from about 68 southward. So this is an accurate representation of what is going on. So going over the past week, we did have one little gale that organized here, but all of it was aimed south. That was like Wednesday into Thursday, March 6th. And there was another little gale, let's go back here, tucked up right along New Zealand with a tiny speck of 26-foot seas aimed north. Yeah, swell for Tahiti for sure, but I don't know how much, if any of that's really going to reach up to the Hawaiian Islands. Oh, there's the anomaly again. It popped back up, on Friday. There you go. And continued, and then it'll disappear here, I think. Nope, didn't do it as of there, but when it got into the forecast, it does disappear. Anyway, nothing else after that. For the North Atlantic, the pattern that has been so dominant with big low pressures pushing off the northeast U.S. coast and then building as it tracking up here in the channel between Iceland and Ireland, that seems to be moderating some. It is still the trend, but you see a little gale here did fall southeast on Friday with 23, 24-foot seas aimed at Morocco. Then another pulse on Saturday, the 8th of March, with 28-foot seas. That swell is arriving now in Morocco and off of Portugal. And then that was pretty much it for the past week. Continuing over to the South Atlantic, pretty quiet pattern. I did a quick review of this. You can see stuff was blowing up, pushing over to the Indian Ocean. But the South Atlantic in and of itself, pretty quiet. We're into Saturday and now Sunday current time. Nothing particularly interesting occurring. And then the past week in review for the Indian Ocean, we'll put this in motion. See right here. Good gale developed on Tuesday night, the 4th of March, with, hard to see here, 39-foot seas, building to 41 feet to 42 feet. That was about it. This was into like Wednesday night and Thursday Pacific time. And then if I recall, I think there might have been another, a small one. There we go with, we get it to right now 32-foot seas. So definitely swell in the water, pushing some degree sideband energy north up into Indonesia and Western Australia. And I forgot to mention, there was this rather strong tropical system that targeted Australia. You've probably seen a bunch about it on the internet, but it actually shows up here. This was on Tuesday, the 25th of February. Let's see if we can get this to go into motion. You see it, not a large system, but falling south down the coast, getting very close indeed to land there, pushing off the coast, and then redeveloping, sort of making a double hit before it finally started to dissipate on Saturday, the 8th of March. So looking forward, what is to come? We're going to do a deep dive in the North Pacific. Yes, it is still more or less winter in the Northern Hemisphere. So we're going to start by taking a look at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, help direct their track. We're looking for a trough, a dip in the jet to the south. You see it right there. That's a very pinched trough indeed, but what that helps do is create a counterclockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure. Of course, low pressure, if it's strong enough, generates winds. As wind gets traction on the ocean surface, creates seas. Seas, as they eventually start radiating away from the fetch area, the lesser period elements of those seas fade away, exposing the longer period elements, and that is swell. And of course, swell, when it eventually hits your beach, turns into surf. So we have a pinched trough off California. That speaks some to the pattern change that we're talking about that's happening in the title of the video, that's happening right now, in that we actually do now have backdoor troughs pushing. One or two have already hit California, and more are forecast. Looking back over here to the west, so Japan's under there. The jet stream is consolidated, pushing off of Japan, but then the northern branch splits off. There's the southern branch there. It eventually targets Baja. The northern branch ridges north. When you get this split pattern, that typically supports high pressure aloft, a clockwise flow, stronger than normal trades. And then the jet briefly comes together here off of, I'll call it Southern California, North Baja. But the general pattern, or the main weather influence for the moment, is this trough with building south winds already along the California coast. As we get into Monday, the trough starts pushing into the coast or towards the coast. Whether it actually moves onshore or not is still a bit debatable. We'll get into that in a later part of the discussion. But then another trough starts building on Tuesday in the, we'll call it the northeastern Gulf of Alaska, falling southeast. Again, there's just this pattern, and eventually moving onshore Wednesday night into Thursday over California. And then let's see, we might have the potential, here we go, yet another trough on Sunday falling down the coast, making it at least to Cape Mendocino and maybe a bit further south than that. So this backdoor trough pattern is really typical of a Modoki La Nina, or La Nina Modoki, depending on how you want to call it. The cold water of this, it's a sort of La Nina, is out here roughly, well, I don't know, somewhere in this region right here, typically north and south of that cold water. Because cold water doesn't support evaporation, you get high pressure. And then on either side, where there is, if there's warmer water here and here, then you get the jet consolidated and dipping further south. We'll get into all that in a bit. Let's go down to the surface, take a look and see what's going on there. Surface level pressure, surface level winds. We know we have a trough here. Look at that. There's a little tiny weak low pressure, probably not swell producing, but low pressure nonetheless. There is a point conception. So off of Southern California, we have a broader gale up here in the North Dateline region with 35 to 40 knot east winds generating seas. We saw that in the previous image. So we get into Monday, the low continues here off of California. A stronger low, let's see. Yep, on Monday we get 50 to 55 knot, I'll call it north to northwest winds. And there we go. aimed a bit better Monday evening or afternoon at Hawaii. 50-knot winds would be actually storm force winds aimed at Hawaii, then quickly fading as we get into Tuesday as the gale approaches the dateline. Another low pressure system Wednesday starts developing associated with another trough off of California, moving onshore into Thursday. The gale on the North Dateline region, just like those prior to it, pushing into the Gulf while slowly fading, generating some seas. And then yet another gale takes shape off Japan as we get into Friday night and Saturday, the 15th of March. Not nearly as organized as the other. Notice winds again building as we approach the weekend. Yet another trough and another gale. This really focused on Oregon, but energy pushing into California. And then by 18Z, that's inland. And we have more lined up off to the west. What is the effect of those winds on the ocean surface? Well, seas, at least that's what we want to see, or waves, raw open ocean waves. Anyway, so here we are, 18Z on Sunday. We know we have low pressure here with 35, almost 40 knot winds. We have seas to 28 feet. Let's see, 29.4 feet specifically. Now, if you're tucked up here in the Aleutians, that's probably shadowed for all regions up in here, but there is just enough energy just south, clear of the Aleutian Islands to make theoretically surf for most of California, north of Point Conception, maybe sideband swell into the Hawaiian Islands. You see seas building theoretically to 32 feet as of right about now. That would be about 4 p.m. on Sunday, or 5 p.m. now that the time has changed. Okay, another gale builds with 23-foot seas off of California, but all aimed south, so really Baja down into Mexico. And then our new gale starts building as we get into Tuesday, the 11th of March, with 37-foot seas. That's about the peak. Just look on either side there. Yep, 37-foot seas, targeting Hawaii pretty well, a good distance away, but still decent shot of swell for the Hawaiian Islands. And yes, for sure, some for the U.S. West Coast. But given that this system is so far away, it's going to be like a southern hemiswell, 20-minute waits between sets, and it's not really aimed at the U.S. West Coast, so low wave count when the sets do arrive. Residual energy from that system moves up into the northwestern Gulf on Thursday into Friday, theoretically, generating 29-foot seas, targeting the U.S. West Coast. Let's see what's behind that. And then the next local gale with, 28-foot seas. But my guess is since a cold front and wind and rain are going to be pushing California, probably not real rideable. We'll take whatever rain we can get. And another beyond that on Sunday night, the 16th of March, with 23-foot seas over the northwestern Gulf. We'll do the same thing for the South Pacific here. Just put this into motion. You see, there we go, 29-foot seas aimed off, but almost falling southeast. Don't know that that really is going to do anything to promote swell. Here's the ice anomaly. This looks more pretty much normal. The big push that made it up here is gone from the current run of the models. Hopefully it stays gone. Hopefully NOAA has fixed that permanently. And after that, well, you get the sense there's energy over here. It's just not making it into the South Pacific. Over to the North Atlantic. Just put this into motion. You can sort of see it for yourselves. String of gales targeting Portugal and Morocco as we get into Wednesday and Thursday, the 13th of March. And then after that, you get the sense that things definitely settling down. The transition of seasons. And that is not what the title of this video is about either. It is not the transition of seasons. It's not MJO related. We'll get into it in a minute. The South Atlantic. Little bit of a gale forecast. 30-foot seas targeting South Africa on Monday evening into Tuesday, the 11th of March. And then another system off of South America here, 29-foot seas, but really falling southeast, so probably no swell expected to result from that. Another gale doing the same thing, higher seas, 34-foot seas, but crashing into Antarctica at 168 hours out. Sideband energy possible, but probably not a whole lot. And then the Indian Ocean. We have our little gale, but here is part of an interesting pattern developing for the Indian Ocean. What was that, 41-foot seas building to 46 feet, 46 feet, 44 feet, targeting, well, certainly Australia, but certainly sideband energy also up into Bali and that area. And then I think there's yet another one forecast behind that. It is falling southeast with 49-foot seas, but then it sort of makes a turn to the east. This certainly would support swell into Western and Southern Australia. You know, the real hope is that it somehow holds together and is able to make it into the South Pacific way early in the season for that, not out of the realm of possibility. You'll have to keep your eyes on it. This is going out 180 hours, so I don't know that I'd believe any of it, but something to watch for. Local wind forecasts for California here, so Southern California there, Central California, San Francisco Bay Area, Northern California, the Hawaiian Islands here. High pressure in control on Sunday. Trade starting to build for the Hawaiian Islands at 15 plus knots. Though this south wind regime, you can see it here just barely. It looks light, but it's enough to create nearly south chop in the San Francisco Bay Area. Maybe further south here, not so bad. This is the beginning of a pattern, the low, winding up off the California coast. Trades on Monday, 20 knots for the Hawaiian Islands, if not more. But you have this south flow for most of California, though it might be offshore up towards Cape Mendocino. On Tuesday, the low pushes into Southern California. This looks good for rainfall for that area. Not so much for snow for the Sierra, but rain is rain. You take it. 20-knot east trades for the Hawaiian Islands. Wednesday, the low moves in. The next low starts spinning up off the coast on Wednesday. Southwest winds 20 to 25, almost 30 knots for North and Central California. Trades 20 knots for the Hawaiian Islands. Thursday, that low moves inland. You still get this sort of high-pressure northwest wind regime, really focused on Southern California. Look at that, 20-knot northwest winds. You don't get that. You don't typically get a rather light wind regime for North and Central California and Southern California getting the brunt of the activity. Trades for the Hawaiian Islands, again, 20-plus knots. Friday, here comes yet another, it looks like, system trying to spin up off the coast, though mainly northwest winds 15 to 20 knots north of Point Conception. Trades finally back off for the Hawaiian Islands, 15 knots. Saturday, here's the next low, south winds for 15 knots or above north of the San Francisco Bay Area. Trades 15 knots for the Hawaiian Islands. And then you get into Sunday, onshore regime north of Point Conception. Things mellow out for Southern California. Trades, not too bad for the Hawaiian Islands at 15 knots. And that gets us to the end of the model run. High pressure in control for the moment. That cold water of the Modoki La Nina hanging right down in this area. The rainfall forecast for California, Southern California, Central California, San Francisco Bay Area, Northern California. Here's our low pressure off the coast at the moment. You see it falls south, basically misses North and Central California. As you get into Tuesday, here it goes, boom, pushing right into all over Southern California and even up to a little bit north, maybe Morro Bay, something like that, and then inland Tuesday and gone. Notice, nothing for the Sierra, but the next system starts building right behind it. You already see spotty snow for the Sierra, rain building along the coast through the day on Wednesday. Good solid snow pattern for the Sierra. Look at that, that's a fair amount of accumulation Wednesday night. Rain the whole way down into Southern California. I would suspect this is more like just light, misty showers, where up here this might be more substantial precipitation. But then as you get into Thursday morning, substantial precipitation for all of Southern California down into Baja and all of North and Central California. More snow for this Sierra. Then Friday, things try to clear out. You see rain along the coast and a little bit of snow showers down to maybe Tahoe, something like that. And then that blows through Friday night into early Saturday morning. But then here comes the next system right behind it, Saturday night into Sunday. Major rain, snow, cold air, high pressure out here, low pressure here, sucking cold air from Alaska down the coast, pushing in so you get precipitation and hopefully some enhanced frozen precipitation in the Sierra. And there we are 180 hours out. The snow forecast dashboard for Palisades, Tahoe. Let's see if I can get that centered there. Okay, good enough. Formerly Squaw Valley. So the first dump Wednesday, Thursday, anywhere from 36 to maybe 38 inches. And then the next dump, this would be Saturday into Sunday and even into Monday, potentially up to about 82 inches total accumulation. Let's go check some other resorts. Kirkwood, South Lake, or South Lake, Tahoe area, doing about the same, 82 inches. Same profile, though. Notice little bits more of scattered showers and snow showers in between. And then Mammoth, being a little bit further south and a little bit east of the crest of the Sierra, getting a little bit less snowfall, but because of their elevation, probably it would be a more drier blower type snow, 33 to 34 inches on the first dump, and then with additional accumulations on the second dump up to about maybe 52 inches, something like that. All in all, things looking very good for the Sierra, and rainfall into the state will take every drop we can get. And the freeze level, this is for, again, Palisades, Tahoe. This is the base of Palisades, Tahoe. I mean, this is pretty good representation for all the Lake Tahoe area, probably even down into Mammoth. 6,200 feet's the parking lot at Squaw. The summit of Granite Chief at 9,000 feet. Now, if you're thinking Mammoth, well, Mammoth's base area, depending on which one you're at, is somewhere between 8,000 to 9,000 feet. Okay, red would be liquid precipitation if there's precipitation. Gray is sleet, like 35 to 32 degrees. The interface between the white and the gray is the hard 32-degree line, the freeze level, and then the blue, 28 degrees or below. That's great for making real snow. But you see, as we get into the 11th and the 12th, this is where the snow starts. The freeze level down at 5,000 feet at Palisades, Tahoe, dropping to 4,000 feet and below. And then for the dump that comes after that, even colder temperatures. This all looks very good for accumulation of snow. And I was up there recently, like just a couple days ago, and pretty much below 6,000 feet, there isn't anything. Yes, driving up and down I-80, the snow line was somewhere like 4,500 feet, but we're talking like just patches of a half an inch of snow in the trees sort of thing. But to get really solid snow coverage, from what I could tell, that snow level is probably about 6,400 or 6,500 feet. And then really to get meaningful base, it really starts somewhere around 7,800 to maybe 8,000 feet. Above that, things actually look quite good. It's just been very high snow levels this entire season, and that's just the way the beast is. All right, so back to surf. What is the surf forecast for a couple of select locations? These are not exact breaks. They are for general areas. For the Columbia River area, each individual break can be higher or smaller, and the wind can change. You got to use your local knowledge and use the tools available on stormsurf.com to sort of tease it out. We're not going to spoon feed it to you, but I also assume that most people watching an hour-long video on the details of El Nino and the MJO and all that have a pretty good idea what they're doing in the water. All right, Columbia River area, surf heights, 10 feet today, fading to about, the 7 to 8 foot range on Monday, down to about 5 feet on Tuesday, then starting to come back up Wednesday in the 8 to 10 foot plus range, Wednesday into Thursday, things backing off on Friday into Saturday, manageable surf, and then back up on Sunday into the 10-foot plus range. Winds you see pretty high at times. You can read the chart for yourself. So it's sort of been the pattern there for a while lately. Let's go look at actual swell heights. 6 feet at 13 to 14 seconds on Monday, fading on Tuesday to 4.5 feet at 11 seconds. A new swell pulls in with 6 feet at 13 to 14 seconds again on Wednesday, building to up to almost 8 feet at 14 seconds on Thursday, down to 6.5 feet at 8 seconds on Saturday, and then back to 8 feet at 16 seconds on Sunday. No break in the swell there. Ocean Beach, San Francisco, surf heights 8 feet on Monday, fading to 6 feet on Tuesday, then back up as the local storms start impacting the coast, 10 feet. But when you see these dropouts, sort of suggests it's going to be pretty crummy conditions. Then fading as we get into Friday, 7 feet down to 5 feet, then back up again on Sunday. Winds, there you go, south at 30 knots on Wednesday, and then persistently onshore at 15 knots Thursday into Friday, and then another bout of south winds at 25 knots on Saturday. Swell sizes Monday, 5 to 6 feet at 14 seconds, slowly fading as we get into Wednesday. Then next bout of swell, 9 feet at 12 seconds, and then that starts fading, still 6 feet at 13 seconds Friday or so. And then wind swell 8 feet at 10 seconds next weekend. San Diego, surf heights in the 2 to 2.5 foot range Monday. But on Tuesday, as the next low approaches the coast, surf heights in the 4.5 foot range, continuing into Wednesday, fading. Thursday, things pretty small. But then as you get into Friday, again, 3 foot, 4 foot type surf, then moderating in size for the weekend. Winds, southeast 20 knots there on Tuesday. Then onshore winds Thursday, northwest to west at 25 knots, and then mellowing out by the weekend. Swell heights, 4 feet at 8 seconds, 3 feet at 13 seconds in the Tuesday-Wednesday range, mellowing out, and then consistently, we'll say 2.5 feet at 12 seconds, turning to wind swell for the weekend. North shore of Oahu, swell is hitting as we speak, surf heights in the 5 foot range, heading down Monday into Tuesday. Next swell hits as we get into Wednesday, surf heights in the 7.5 foot range. Look at the trades, just nonstop, 22 knots the entire time. Then fading, both trades, swell height 5 feet, 4.5 feet sort of thing is Friday, Saturday, and Sunday. Trades mellowing out considerably. So it's just the next 5 days we have to suffer through with strong trades. And swell heights, 4.5 feet at 12 seconds, now fading to in the 3 foot at 10 to 11 second range, dropping from there. Next swell hits, building to 5 feet at 15 seconds on Wednesday, and then another pulse on Friday, 3.5 feet at 15 seconds. So things mellowing out compared to maybe a couple of weeks ago, but still, there is surf. Take what you can get while we have it. And just for fun, looking at Indonesia, since things appear to be waking up a bit in the southern hemi in the Indian Ocean. Surf heights, swell hits, 10 feet on late Tuesday into Wednesday, mellowing out, and then in the 5 to 6 foot, maybe 7 foot range next weekend. Winds pretty light the entire duration. Swell heights 6 feet at 16 seconds. That is real swell, and even building, from 3 feet at 19 seconds sometime on Monday. That mellows out. And then we get another pulse in at about 4.5 feet at 16 to 17 seconds on Sunday. So it appears the season is starting in the Indian Ocean. All right, let's go take a look long term. What's going on with the two major weather oscillations that affect surf, precip, and everything else, depending on where you live? It is the MJO, the Madden-Julian Oscillation, and ENSO, the El Nino Southern Oscillation. We'll start by talking about the MJO, the Madden-Julian Oscillation. There are two phases to it, the active phase and the inactive phase. The active phase is on one side of the planet, the inactive phase on the other. There we go. They rotate around the planet on the equator, moving west to east. The active phase is our friend. It is effectively a low pressure system. When it moves south of where you live or into your ocean, because it's low pressure, it takes warm, moist air that's down at the ocean's surface, lifts it aloft up into the atmosphere. That warm, moist air supplies energy to the jet stream. The jet stream gets stronger. It does not split. It consolidates. It starts digging out troughs, and that creates storm, and which creates surf. The inactive phase is a high pressure system. It creates downward falling air that is effectively steals energy from the jet stream. The jet stream gets weak and splits, and if anything, supports high pressure at the ocean surface. Stronger high pressure means stronger trade winds. And yes, that can create wind swell, but it doesn't do anything for creating long period ground swell. All right, so if you know that the inactive phase of the MJO supports stronger trades and the active phase of the MJO dampened trade winds, we can use this data from the TAO buoy array, a series of buoys strung across the equator in the Pacific, to sort of get a sense of what's going on MJO-wise. So this is the East Pacific, West Pacific here. That's New Guinea. That's the equator there. Date line right there. We're just looking at the arrows. And these are wind sensors on the buoys. And just looking here, you see just the length of the arrow. Winds out of the west, very weak in the East Pacific. Then they start building to like sort of looks like normal trade strength over the Central Pacific, and then strong trades in the West Pacific. But it is not the trades that really matter from this game that we're playing here. It is the anomalies. Are the trades stronger or weaker than normal relative to what is normal for this time of year in this location? They call that anomalies. So looking in the West Pacific, these literally show the anomalies. Winds are stronger out of the west than normal. This would probably be really indicative of the active phase of the MJO. Trades normally blow from east to west. They're switched direction. So this probably says the active phase of the MJO is somewhere here. You get to the Central Pacific, and it's just dead neutral. And then you get to the west, that is the East Pacific, and West Pacific over here, trade stronger than normal. So that probably indicates the inactive phase of the MJO over here. What is the forecast for trades for the coming week or 2 weeks, for the next 14 days? All right, so this is a chart. It's the entire planet, 180. That's the date line right there. The far West Pacific starts at 125 east, so right there. Far East Pacific is somewhere over around 80 west, but it's this area between, it's the West Pacific that really matters. When the active phase is sitting over that gooses up the jet stream, gives it momentum, and then the jet just can plow the whole way across the Pacific alone based on that momentum. But, okay, blues, purples, those are easterly anomalies. That's probably talking the inactive phase of the MJO. Reds, that's the active phase of the MJO. So California's at 120 west. So it looks like the active phase of the MJO from February 12th to about today has been south of California, and it looks like it's starting to move over into the Atlantic after that. This is today's date. While the inactive phase of the MJO is starting to set up over the dateline region and is forecast to build for the next 2 weeks. Also notice, though, a new potential active phase of the MJO building in the latter part of March. So just looking at this, it suggests that, well, first couple of weeks of February are probably good for surf as the active phase was moving across the dateline. Now, inactive phase setting up for the next 2 weeks, probably not great for surf, but again, that might be feeding that backdoor trough pattern. That means high pressure over the dateline. That would allow the jet stream to come crashing down. It ridges over the high pressure, then falls south down the California coast, supporting that rain pattern that we've been getting. All right, let's look at some other models going out 2 weeks. A different view, though. This is outgoing long wave radiation. That's just, are there more clouds than normal or not? Okay. If you have the active phase of the MJO, it's taking warm, moist air and, oops, there we go, lifting it aloft. That warm, moist air will eventually condense as it hits the upper atmosphere, creating more clouds than normal for this time of the year. So, and that would show up as blues. The reds are the exact opposite. If you have downward falling air, it's dry air. You would make clear skies. That would be the inactive phase of the MJO. All right, so let's get ourselves oriented. This is a statistic model, by the way. South America, Central America, New Guinea, Australia, EQ is the equator, dateline right there. This suggests inactive phase of the MJO over the all-important Kelvin wave generation area, the West Pacific, while the active phase is somewhere in the Atlantic into the Indian Ocean. 5 days from now, same sort of pattern. 8 days, 10 days from now, same thing, but the inactive phase getting weaker. And then 15 days from now, 2 weeks from now, the inactive phase all but fading out, active phase seeping into the far West Pacific. Statistic model says that. Dynamic model, looking pretty much the same. Inactive, 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 a little bit stronger, but a building active phase pushing into the West Pacific. In fact, there's the statistic model, final frame. There's the dynamic model, pretty well in sync. That suggests that, yeah, things aren't going to be great surf-wise for the next 2 weeks, but then you go out beyond that, maybe an improving pattern. Let's keep digging. Same two models here, statistic model here, dynamic model here. These are phase diagrams. These are plotting exactly where the active phase of the MJO is supposed to be. How do you read this chart? Well, the MJO moves from west to east, from the Indian Ocean, over the maritime continent, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. The heavy dot is where the active phase is right now. So somewhere in the far west Indian Ocean. Okay, the further the dot is away from this circle, the stronger it is. So we'll call it moderate active phase in the West Indian Ocean. Here's the track, 3 different member runs going out 2 weeks, 14 days. This puts the active phase squarely over the maritime continent and weak 2 weeks from now. The dynamic model, same sort of thing, basically giving very similar results. So for this day, the two models are in sync. Upper level model showing potential for precipitation, same sort of deal. The reds and orange, dry air, no precip. The greens, wet air, favorable for precip. So that'd be inactive phase. This would be the active phase. Now, since this is up at Jetstream level, it probably runs about a week ahead, if not more, than what actually happens at the surface. The jet stream sort of races along the planet, and then down at the, it's up at 30,000 feet. At the surface, the pattern drags sort of behind because there's land and creates friction, etc. All right, South America, Central America, New Guinea, Philippines, you get it. The equator right there, dateline right there. Each of these frames is for 5 days. This goes out 8 frames, so 40 days into the future. So inactive phase over the Pacific, moving out, and the active phase starting to come in the end of the month, 24th of March. So add a week to that. We'll call it the 1st of April, something like that. And then active phase in control pretty much all of April. And then let's see, where are we at here? And then theoretically, inactive phase showing up about the end of April. Now we take a look at a model going out a month. This is the CFS model. It is a dynamic model. It is NOAA's primary long-range forecast model. It actually does a good job. This also shows you the MJO. So it's not only the east-west component of the wind, the blues, easterly anomalies, the reds, westerly anomalies, but the MJO is a contour here, the black contour, solid contour, active phase of the MJO. You see is back in December, westerly anomalies and westerly anomalies, but the easterly anomalies holding over the dateline region. There's the dateline. That, of course, because La Nina is in control, cold water is over the dateline on the equator. Inactive phase of the MJO, here's another active phase back in January into February. Here we are today. Inactive phase, setting up, moving across the dateline region, Kelvin wave generation area. Forecast for about 2 weeks, and then the active phase is going to take its turn with westerly anomalies. But again, because of La Nina, the westerly anomalies don't penetrate. It's kind of the way it is. La Nina would have to fade, and when it fades, then westerly anomalies penetrate. La Nina favors the inactive phase of the MJO and easterly anomalies over the dateline. The active, or the El Nino, favors low pressure over the dateline, or lower than normal pressure, westerly anomalies in that region, and better potential for storm production. And now to the title of the video. Let's see if we can pull that up right here. Sorry, look at it. Two weeks before a significant pattern shift? Really? Well, this model has been predicting a significant pattern shift for 2 or 3 months now, and it looks we're in the 2-week window, and the model isn't changing a bit. So let's take a look at this. This is 850 millibar zonal wind anomalies. Again, the blues, easterly anomalies, the yellow, westerly anomalies. Past performance is down here. The forecast is up here. Dateline right there. Far West Pacific starts at 125 east, so right there. All right, so you see here's our current inactive phase of the MJO with easterly anomalies. It's supposed to go for 1, 2 weeks, and then notice after that, easterly anomalies that have dominated over the dateline vaporize. And what replaces it? Westerly anomalies. Now, I'm not saying this is a El Nino developing pattern, but what this does suggest is just a return to normal over the dateline region. In fact, let's overlay the MJO here. All right, so here's our current, the dotted contour, inactive phase of the MJO. You get to March 25th, boom. The active phase actually a week from now starts building in the West Pacific, works its way not only to the dateline, but the whole way across the Pacific, with westerly anomalies almost reaching a point south of California. And then even after this active phase fades, the inactive phase shows up. Look at that. Westerly anomalies, again, continuing after that. Now, do I believe a model a week out? No. Do I believe a model 3 months out? No. But this model has been one heck of a tease, continuing to suggest this. And it's been solid at somewhere around the 24th, 25th of March for months now. So this looks favorable. What is driving that? Let's overlay the low pass filter. Remember I talked about La Nina is effectively high pressure over the dateline? Well, this dotted contour is your La Nina signal with 1, 2, 3 contour lines. The third contour line is forecast to disappear April 10th. The second one, no, maybe May 1st. And notice the final contour starts pushing east of the dateline by about mid-May. The low pressure bias, which has been over the maritime continent this entire winter, though normally during a strong La Nina, it would be even further west than this, but it's hovering right here's the entrance to the Pacific. It's been hovering just over the maritime continent, supposed to hold, but then as you get into the early part of May, it starts creeping east and continues, filling the entire central Pacific at the end of the model with a second contour developing. Now, do I believe that? No, of course not. But all in all, this trend looks very promising. And with the change in seasons and, the fact that this is a Modoki La Nina, and we'll get into more on that in a little bit, it suggests that this La Nina is not very weak, and whatever energy it has in starting with the advent of these westerly anomalies, if they materialize, that either is signaling the shift in the pattern or is going to cause the pattern to change. So something to keep our eyes on. All right, so let's dig into this La Nina situation. First, let's go subsurface. Subsurface temperature anomalies, or actual water temperatures in the Pacific. This is the West Pacific here, East Pacific here. This is data from the TAO buoy array. These are the actual anchor lines on the buoys. The X's are sensors on those anchor lines. They collect data, and you just get a profile of where the warm and cold water is. During El Nino, warm water would be in the West Pacific. During La Nina, because trades are blowing stronger than normal, they take all the warm water, ball it up into the West Pacific. The 29-degree isotherm, 29 degrees centigrade, is where it was last week at about 173 east. The 24-degree isotherm, pretty much solid, though I noticed a buildup of warming waters here in the upper reaches, the upper 5 meters of the ocean surface, something like that, suggesting that warm water, though not super strong, is maybe building in the east. Let's go look at the anomalies. Difference from normal for this time of year. Warm water in the west, warm water in the east. Here's your La Nina cool pool subsurface, 3 degrees centigrade below normal, centered at, let's get some data here. Oh, there's 150. That would be about where Hawaii is, roughly, south of Hawaii, and then trying to ease into Ecuador in that area, but it's been teasing at that all winter. Doesn't seem to make it. If anything, looking at the contours here, the escape route for this cold water is probably up this direction and out, just caught by the trades and gone. Let's go look at some other data. This is the same data set, the TAO buoy array data, but it also has satellite data, sea surface height, which one can infer subsurface sea temperatures at, overlaid. Here is your warm pool, if anything, building to about 165 west, but getting denser back in here. Here is your pool in the east. I think it's a bit underrepresented in this image. And then here is your cool water. I mean, even from a week or 2 weeks ago, there was far deeper blues and much colder temperatures in this area. It looks like whatever cool pool there is here, the source of the upwelling or the source of the cool water has been cut off. And a little bit at a time, this seems to just be getting homogenized and genericized and kind of washing out. Let's go look at some more data. Here is the satellite data. It's effectively updated every 5 days. Here's data from March 4th. Okay, this is not temperatures. This is the height of the ocean. Here's the equator here. Here's the dateline here. That's New Guinea there. That is Ecuador there. Galapagos right there. The height of the ocean, all right? Why does that matter? Well, if you have colder water at depth, it contracts. And when it contracts, it makes a divot on the ocean surface. So if you have a satellite that's mapping the ocean surface height, taking out the waves, the wind waves, and the tide, you can see subtle differences, like these are centimeters, 10 centimeters, 15 centimeters, 5 centimeters. So subtle differences in the height of the sphere of the ocean. If you have warm water depth, it expands and will displace water above it up, creating positive anomalies like there. All right, so what are we looking at? Well, right here, look at that. We even have some positive anomalies along Ecuador. This was more negative even a week ago. Now it's almost, where's the scale down here? Almost neutral. I mean, it's weakly negative, but not much, suggesting a little bit of cool water. Your main focus of your cold water is right here. Where is that? 160 west, or there's Hawaii right there. So south of Hawaii in that area. And not even on the date line, it's 15 to 20 centimeters, which is still pretty cold, but straddling in two lobes north and south of the equator. And if anything, I'm waiting to see this actually starting to move off to the west. It hasn't done it, but it's certainly not moving east. In fact, we got another view of this. Equatorial ocean heat anomalies. This goes back to March of 2024. And you guys have seen this before, so I'm not going to go into all the details. But you see in the West Pacific here, our building pool of warm anomalies. In the east, our crashing pool of cool anomalies. In fact, the lightest shade of blue here is the whole way out to 140 west. It has not been that way for a year now, suggesting that this big pulse here in January, February of the inactive phase of the MJO and east anomalies and the cool water is probably the last pulse or the last pool of cool water associated with La Nina anytime soon. Let's keep going. Sea surface temperature anomalies. That's what really matters. It is the water temperature on the ocean surface that supports evaporation. The warmer the temperatures, the more evaporation. Likewise, Cooler temperatures cut off evaporation, steal fuel from developing storms. All right, so South America, North America, Ecuador, 0. The equator, dateline right there. Cool water. It's only 5 degrees north and south of the equator that matters. All this other stuff, interesting, but it is that thin little stretch on the equator that really drives the planet's air circulation. And here is your La Nina, Modoki La Nina signature. Cooler than normal waters right there. They are definitely not as dense, not as concentrated as they were a couple of weeks ago. And if anything, maybe easing off to the west a little bit. Notice this building, it almost looks like El Nino. This is the classic El Nino kind of signature, though there isn't anything really in the atmosphere to support that. But certainly westerly anomalies in this area. You saw that probably from the active phase lingering over here for the past month. Creating westerly anomalies, suppressing trade winds, which allow the sun to start baking the ocean surface and warming it up. So there you go, the last vestiges of our Modoki La Nina there. Sea surface temperature trend for the past 7 days. Again, Ecuador there, the Galapagos, the equator right there. Warming temperatures, as would be expected, along the East Pacific. Notice a little bit of cooling here along Peru developing, but not particularly marked. And then over here, where supposedly all the cold water is, temperatures there even warming, suggesting the Modoki La Nina cool pool, if anything, is breaking up and getting warmer. That said, we do have the inactive phase of the MJO forecast to set up for the next 2 weeks. We'll see what sort of a dent that puts in all this. Sea surface temperature trend in the Nino 1.2 area, the area right there by the Galapagos and Ecuador. Since January 28th, you see a steady rising pattern. Today's value, plus 1.433 degrees. That's definitely much warmer than normal. Here's normal right here. Again, this isn't corrected or anything, but it gives you a general idea of what the trend is. In the official El Nino monitoring region, the Nino 3.4 region, today we are so close to being dead neutral, minus 43 thousandths of a degree below normal. Now, you know, 1 day doesn't mean anything. We have to see how this goes for the next couple of weeks. But for right now, trend is in the right direction. The weekly sea surface temperature anomaly values for the Nino 3.4 region right here. Here's the actual value and the difference from normal. Minus 0.2 degrees below normal. And you see the trend has been from minus 1.1 degrees. That was the peak of this Modoki La Nina on Christmas. And then steadily rising from there. We are very close to being at the end of this, fortunately, short-lived La Nina. Then finally, what does the atmosphere think is going on? We look at the difference in pressure between Darwin, Australia, in the Indian Ocean maritime continent, and Tahiti, clearly in the central South Pacific. When pressure is lower in Tahiti, the index goes negative. Well, today's value, plus 6.17. Where has it been? Well, it's been hovering somewhere just above neutral. There you see it was negative for a good run back in February. That's probably the active phase of the MJO. For the past month, all in all, not particularly strongly positive. The 30-day average SOI takes, sort of puts a trend line through it, takes some of the noise out of it, plus 2.52. So pretty much just barely neutral. Where was it a month ago? Well, we were up at 13.68 in February 13th, steadily falling from there. The 90-day average, that's your El Nino La Nina indicator, plus 5.08. Where were we a month ago? Plus 9. So all these indicators say that pressure is falling in the Pacific relative to the Indian Ocean. Here's a 30-day moving SOI graphed out. The neutral range, plus 7 to minus 7. And you can see here is our La Nina pattern since March 2024, slowly building, and then looks like it peaked out here in December, January, February sort of thing. Today's value, almost at dead neutral. Put a trend line through this, you can see the rising pattern, but starting right about here, it looks like it's leveling off. So we'll have to see where this goes. In fact, let's go look at the forecast. Here is the CFS version 2 model forecast for sea surface temperatures in the Nino 3.4 region, sea surface temperature anomalies. So let's see, January, February. In March, this would be mid-March. Temperature is supposed to be about 2.5 degrees below normal. That's about where it is already. Forecast in April, maybe dipping some to 0.4 of a degree, and then just hovering right below neutral until we get to October, and then pretty much dead neutral. There's a corrected version of this, PDF corrected. It's pretty much painting the same picture, suggesting La Nina dead, and we're moving into ENSO neutral as we get out of the spring unpredictability barrier. So for right now, surf-wise, yeah, there's going to be surf, nothing great. California really is going to be getting lots of rain. I think that's the big story. Backdoor troughs in control. This is typically what you would expect during a Modoki La Nina. It took us till now to finally get in the groove of Modoki La Nina. There were some other things going on. The strong low-pressure bias right over the maritime continent earlier this winter really fed the jet stream, but that was good. It made great for surf, didn't do so much for precipitation. Now California is going to not get the surf, but it will get precipitation. I think we should take all we can get and be thankful for it. Hawaii should do pretty good surf-wise, though, because the bulk of the storm production looks like it's going to be west of the dateline, that area. So Hawaii, still pretty active surf pattern for that region. Looking longer term, looks like our Modoki La Nina, we will know in 2 weeks, fingers crossed, whether it fades out or not. But so far, everything seems to be on track. We'll have to see what actually materializes. Never trust a computer model out 2 weeks or more. Anyway, that looks favorable. And as we get into the, we'll say, later summer and fall, we should be ENSO neutral. It'll be interesting to see how this affects the southern hemi summer swell production relative to California and Hawaii. I would expect the season to start off probably pretty quiet and then start building as Modoki La Nina fades from the atmosphere. All right, that's the forecast for this week. If you enjoyed the video, give us a thumbs up. If you haven't subscribed, and we do appreciate everyone subscribing, click the Stormsurf icon down in the lower right-hand corner of your screen. If you have a comment or question, write it up down below. We'd be happy to respond. And if you'd like to make a small contribution to the cause, you may. Hit the super thanks button down below, the heart with the $sign in it. In fact, if it doesn't show up right below the video, there's a little circle with 3 dots in it. Click that, and it's buried in there. That's just an expansion of all the options that YouTube gives you. And look for the heart with the $sign in it. So with that, we are done for this week. We will do it again next week, same time, same channel. Pray for surf, pray for rain. I think we're going to get a little bit of both, depending on where you are. And we'll see you next week.